Hey guys, so now we're going to look at how systems of equations look like when you're looking at real life problems. And this image that you see with these two cabs, yellow cab versus blue cab, kind of capture everything we're going to be talking about, which is looking at two situations and where they have a common value, a common amount. Like if you compare the yellow cab as a function of how many miles you ride in that cab, how much it costs you. If you look at that line and then you look at the line for the blue cab, how much that costs you for a certain number of miles, where they meet, where they intersect, this is the solution of the system. Oh, let me write in regular pen. This is called the solution of the system. We found this point of intersection with regular graphs, but now it's with a real life story. So this is telling you that for 3 miles, both cab companies will cost you $8. See how they meet at that point? That's what they have in common. So for 3 goes with the miles on the x-axis. 3 miles, both companies cost $8. So the point of intersection 3, 8 has a specific meaning with relation to the story. All right, so if you look at another example, next week Marnie wants to attend either Carnival A or Carnival B. Carnival A charges $6 for admission and an additional $1.50 per ride. Carnival B charges $2.50 for admission and an additional $2 per ride. Let A of X represent the total cost of attending Carnival A and going on X rides. Let B of X represent the total cost of attending Carnival B and going on X rides. Write a system of equations to represent the situation. So Ms. Espinoza will pause the video and you guys can write down 2 equations. A system of equations is telling you that you need to write 2 of them. 2 equations. Try to write down one for Carnival A and one for Carnival B. Okay, so Carnival A says that they charge $6 and an additional $1.50 per ride. So A of X is the cost equals, and I'm going to switch the order. I'm going to say $1.50 times X rides, because they said X rides, plus the $6 for admission, so that I'm making it look like Y equals MX plus B. So it's really like Y equals 1.5X plus 6. And then for Carnival B, they charge $2.50 for admission and an additional $2 per ride. So B of X equals $2 per ride, 2 times X rides, plus $2.50. So again, if you think of it as Y equals MX plus B, Y equals 2X plus 2.5. And we need to graph this system. So notice that there's no scale given. So I'm going to draw my Y-axis here and my X-axis here. And I'm going to think about y-intercept first. I need this y-intercept to be 6 and this one to be 2.5. So on my y-axis, I'm going to count. I want to count by, let's see, every 2 of them is going to be 1, I think. No, I'm going to go by ones. 1, 2, 3, 4, 5, 6. That'll be the first y-intercept, 6. Okay, so I'm counting by ones. 2, 4, 6, 8, 10. And I want my slope of that line with the y-intercept of 6 to be 1.5. So that means I'm going to go, it's kind of hard to go up 1.5. So 1.5 could be rewritten as 3 over 2, right? 1.5 is like 1.5, which is 3 over 2. So if I go up 3 lines, 1, 2, 3, and across 2 lines, that should work out 1, 2, 3, 1, 2. Now this isn't going to get me very far, so actually, you know what, I'm going to redo this, and I'm going to go, I'm going to spread the scale out down here. I'm going to make this 1. I'm going to make every 2 squares 1, so that it spreads it out. So when I go up 3 and across 2, 1, 2, 3, I'm going up 3 lines, but then I'm going across 1, 2, 3, across 2 like this to this one here. So I'm going really like up 3 squares and then across 4 squares, because every 2 squares on the x-axis represents 1. And that'll make my graph a little bit nicer looking. So I'll go 1, 2, 3, and then across 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4, so that it covers more of the graph. 1, 2, 3, 1, 2, 3, 4. And there's my first line, which represents carnival A, or A of x. Okay, so for the second equation, b of x, that one has a, I'll do that one in blue, it has a y-intercept of 2.5. So we're going to go right between 2 and 3. We're going to be right in the middle there, like this. And that slope is 2 over 1. So we're going to stay in the middle, and we're going to go up 2, which will be right between 4 and 5, and across 1, which is really 2 squares. That's up 2 over 1. So if you count that, I'm staying in the middle, going up 1 square, up another square in the middle between 4 and 5, and then I'm going across 1, which is, according to the scale, is 2 squares. And then I'm going to repeat it again. 1, 2, and then across 1, which takes me to here, and then 1, 2, and across 1. 1, 2, and across 1. And I'm looking, oh, that's not 1. I'm looking for the point of intersection. Let me keep numbering here. We said we're going to go 3, every 2 squares is 1, 4, 5, 6, 7, 8, like this. So I'm going to keep going with the blue line. 1, 2, and across 1. And I'm looking for the point of intersection. 1, 2, and across 2 squares, which is 1 here. They're not intersecting, they're close, but this point is up here. 1, 2, and across 1. This is exactly where they touch, right there, this one right there. And then I'll just keep going, one more, 1, 2, and across 1. So this line, it's really close. It's very, very exact. And I don't know how to use a ruler on this thing, but I would definitely use a ruler. And that's the b of x line. So they intersect, very important concept, they intersect at this point. I'm going to highlight it in yellow right here. And so that point of intersection, which has the coordinates 7, comma, and then if I keep numbering, this is 9, 10, 11, 12, 13, 14, 16, 7, comma, 16. You have to think about what that means. Now your x-axis has to get labeled. Your x-axis said x is the number of rides, and your y-axis represents the total cost. Okay, so this means 7 is the number of rides. That means 7 rides, 16 is the cost, $16, and this is where both carnivals meet, where they're both the same. So for part C, it says determine the number of rides Marnie can go on such that the total cost of attending the carnivals is the same. So the same, when you see the same, they're saying point of intersection. Right? And they said determine the number of rides. So we know 7 is the number of rides. Now if they asked us about the 16, you would say they both cost $16. They didn't ask you that, but both cost for both. I'm going to write cost for both is $16. That's the meaning of the 16. All right, so you're going to have a couple of these to do for Friday, very similar to this. One is with a graph. The other one is going to be like number 2, example 2, which I have to do in a separate video because this is getting too long. All right.